Hi, my name is Hamza. I'm from Sri Venkateshwar College of Engineering. I'm here to represent my internship work titled Microcontroller System Based Automated Measurement of Resistance of TFR. My internal guide is Professor Prakasha Sir, Assistant Professor Department E&CE, SVC Bangalore, and my internal guide is Mr. Balagangadharam B, Manager R&D Department, KHMD Bangalore. Here is a list of contents in this internship work, and this is a certificate provided to me for my internship work by the company. Company profile. The Karnataka Hybrid Micro Devices Limited Company is a public limited company based in Bangalore. The company was incorporated in 1984 and is primarily engaged in manufacture of semiconductor devices such as diodes, transistors, and other electronic components. Products are used in various applications including automotive, telecommunications, power supplies, and industrial controls. The company has a team of highly skilled professionals who work on developing innovative products and improving the quality of the existing products. Introduction. The microcontroller is a system called as the microcontroller and a thick film resistor are used in this project. The thick film resistors are commonly used in electronic circuits and is important to accurately measure the resistance of a proper circuit operation. The system will use a microcontroller to control the measurement process and display the measured resistance values. The system will always be able to store the measured values for later analysis. This will eliminate the need for manual measurements, which can be time consuming and prone to errors. The project will involve designing and building of measurement circuit, programming the microcontroller and testing the system to ensure accurate and reliable measurements. The end result will be a system that can efficiently and accurately measure the resistance of the thick film resistor, making it valuable tool for electronic engineers and technicians. Objectives of this project are to understand the concept of microcontroller and thick film resistor, to develop an automated inspection of TFRs in the production line, to reduce the human errors in calculation of resistance, to improve the accuracy, which can be extensively utilized by the resistor manufacturing industries for testing purpose, to overcome the difficulty in providing the resistance values in large production industries. Plan of work. The plan of work for this to complete this internship work were divided into 4 weeks. Like in the first week, we have conducted the research and the principles and methods for measuring the resistance of a thick film resistor and studied the datasheet and technical specifications of microcontroller and other components and planned the project timeline and identify the necessary tasks and milestones. In second week 2, the select and acquire necessary components such as microcontroller resistors and ensure the compatibility between the components and verify that they meet the project requirements and design the circuit diagram and layout for the microcontroller system, prototype the circuit on the breadboard to verify its functionality and make necessary adjustment. And in the week 3, we have developed the software of the microcontroller and test the software on the prototype circuit and debug any issues that arise. In week 4, we validate the system by measuring the resistance of various thick film resistors with different tolerances and compare the results with the expected values and document the project design, implementation, and test results in a report. This is a block diagram of this project. Like we have to find out the resistance of a thick film resistor in a 18-step potentiometer. Like we will take the voltage in as a reference voltage. Like we will give it from the microcontroller board, and two resistors are connected in series to each other. Like if two resistors are connected in series to each other, The same current flows through it, but the voltage flowing through it is different. One resistor is known to us and another resistor is unknown to us. The unknown resistance we have to calculate. And the AD to D converter, that is analog to digital converter, converts the analog signals into the digital converts or digital signals into the analog converts. Here the microcontroller we have used is microcontroller 2560 board. Working. The system consists of an Arduino board, voltage source, resistor, and a thick film resistor to be measured. The microcontroller generates a known voltage across the thick film resistor. The current flowing through the thick film resistor is measured using current sensing resistor and analog to digital converter connected to the microcontroller. The microcontroller calculates the resistance of a thick film resistor using Ohm's law. The measured resistance values is displayed on the digital display or sent to the computer for further analysis. The system can be calibrated or by using known resistance to ensure the accurate measurements. Working formulas. The working formulas we can do this project to measure the unknown resistance in the two different ways. Like we can use Ohm's law or we can use voltage divider rule formula. If we use Ohm's law, like we know that Ohm's law formula, I is directly proportional to V and inversely proportional to the resistance. The V refers to the V out and R refers to the known resistance. And if we find out the voltage drop between the two resistors, the voltage drop can be found out by how much voltage in and how much voltage out. Voltage in minus voltage out gives the voltage drop across the resistors. And Rx refers to the unknown resistor. And Rx, if we want to find out the unknown resistors, then R is equals to V divided by I. Then we will find out the V by measuring the voltage drop and current flowing through the two resistors is same. And so that we are giving V in as a 5 volts, then unknown resistance values can formula can be written as a 5 minus V out divided by I. And in voltage divider rule formula, we can the voltage divider rule formula is V out is equals to V in into R2 divided by R1 plus R2. Then we have to find out the R1 is unknown resistance to me. To find out the R1, we will modify the formula to calculate the unknown resistance. And here is a flowchart of the system. First, initialization of the system has been done, and the TFR is, and we will check whether the TFR is connected to the jig circuit properly or not. If it is not properly connected, we have to check it and properly connect it and measure the resistance. And third step is to measure the resistance. We will measure the resistance of the TFRs. If the good condition TFRs, the values lies between 91.8 to 94.2. If the TFR values are beyond that, then it is not a good condition TFR. If it is below that, then it is not a good condition TFR. If the value ranges between the 91.8 to 94.2, then it will print as pass. And if it is high or low, then it will print as low. And we will tabulate the values and then end. Hardware and software components required. Hardware requirements are Arduino Mega 2560 and thick film resistor, connecting wires, non-conducting board, jig circuit, and USB cable. Software requirements are Arduino IDE. Advantages. Advantages are automated inspection in TFRs in the production line. It provides an efficient working, low cost and time saving, economical, and provides fast and accurate values of the resistor, reduces the reading and interpolation errors. Disadvantages are there is a voltage limitation. If it is increased beyond the limit, it will be damaged. Correct contact with the jig circuit of the TFR should be done carefully. Applications. TFRs are used in the petrol level sensor in vehicles. It can be used as a pressure level value indicator in the industries. TFRs are used in aircraft instruments, gauges, flight control systems. In medical systems, this can be used as a heat monitors and diagnostic equipment. In other side, it is also used in audio systems like radio receivers, DVDs, and also in amplifiers and equalizers. It is also used in air coolers, machines, and ventilators, and also in heaters. It provides major application in defense sector and in aerospace. This can be also used in a power suppliers in setup or step down converters input and output voltage. Results. This is the picture of the TFR jig circuit. This is a jig circuit when the pressure is given to the jig circuit, and if we keep the thick film resistor of a 18-step potentiometer here, and if we give the pressure to the jig circuit, the pins will come down and settle down at the on top of the jig circuit, on top of the thick film resistor 18-step potentiometer. The above figure shows the this figure shows the jig circuit when thick film resistor is not contact with the jig circuit. Since it senses no resistance, the LCD screen displays the resistance values as infinity. The thick film resistor value ranges between greater than 91.8 and below 94.2. Since measured value is infinity, and then it exceeds the range value. The output on the LCD screen displays as high. Since the infinity is it is not in the range of 91.8 to 94.2, then it will displays as a high. And in another condition, if the thick film resistor is in contact with the jig circuit properly and measuring the resistance values. As I say, that the good condition TFR lies in the range between 91.8 ohms to 94.2 ohms. Like we can see in this screen, like TFR4 is 94.74, that is in the range of 91.8 ohms to 94.2 ohms, then it will print as pass. Like we can see here, like TFR8, the range has gone above the range, like 96.03, that is not in the range, so it will print as high. Conclusion. In conclusion, the microcontroller system based on automated measurement of resistance of thick film resistor has significant advantages in terms of accuracy, speed, and repeatability. It allows automation and measurement process, reducing the need of manual measurements and increasing productivity. The use of microcontrollers also provides better tracking and analysis for resistor performance over time, which is useful in various industries such as aerospace and automotive. Data obtained from the automated measurement process can be stored and analyzed using software, providing valuable insights into performance of a resistor. The future scope of as advancements in microcontroller technology can lead to even greater accuracy and precision in resistance measurements. And here are the references to complete this project successfully. And thank you. I thank my external guide, the Mr. Bala Gangadharan B. Sir, who supported to do this project in the company. Thank you, sir.